Hi, I'm John Paulraj, and on this particular video, we're taking a look at the complete solutions for paper 1, time zone 1, May 2025, IB Math Applications and Interpretations. This is going to be complete solutions, means we're going to have every logical reasoning. So it might take some time, some more time. So this is part 1 only, just the part 1. So don't miss out all the other parts. Okay, let's roll. That is quite a mouthful. I need to really practice saying that topic again. Paper 1, time zone 1, May 2025, IB Math Applications and Interpretations. Anyway, you get the point, okay? Let's just get straight to this question now. A child's game, this is question number 1 from this paper, okay? A child's game is played by making paths in the snow. First, 2 circular paths are made using the same center, O. The radius of the smaller circle is 2.8 meters and the radius of the larger circle is 4 meters. Additional paths are then made from O to the outer edge of the larger circle, dividing the circle into 5 equal sectors. So these are the 5 sectors, as you can see, and the larger circle has radius 4, the smaller circle has radius 2.8, as mentioned in the question. For your calculations, ignore the widths of the paths. That's clear. Okay, they've given a key. That's very good. That's what IB thinking is all about, right? Every time there's a diagram illustrating a real life situation, make sure there's a key to be able to interpret. That is hinted for your IA. If you're making any diagram, a chart, a graph, make sure there's a key interpreting what that is, okay? So each region between the paths will be colored orange. So let's use some color that's close enough to orange. That's the area of the shaded region, I think they are asking us, but they have asked this question in a very interesting way. Okay, check out the language in the question. Maureen has enough orange dye to cover an area of 6 meters square. So instead of directly asking us what is the area of that shaded region, that means the area between the 2 sectors, they've asked the question, show that Maureen has enough orange dye to cover the shaded region. So basically what are we looking at? We're looking at showing that the area of that shaded region, the area between the 2 sectors, is less than 6, less than or equal to 6, okay? Because you need more, the quantity, the quantity that of dye, if she is more, that means, she's safe. You don't want to fall short, right? So what's the formula we're going to use? We're going to use the formula. I'll put that, okay? So the required area, is there a space here? Here you go. So the area, or I'm going to write down required area, okay? That's safe to say, is going to be theta over 360 times pi and R1 square minus R2 square, okay? Where R1 is the radius of the outer circle, R2 is the radius of the inner circle. And the value of theta is 72. And how do we know that's 72? Well, basically because we know that there are 5 sectors, right? 5 equal sectors. It says in the question 5 equal sectors. That means the angle subtended between each sector here. The angle is 72. How? 360 divided by 5 should be 72. You can check that on the calculator if you want to, but you're going to go ahead and write it down and say this is pi, and the outer circle radius is 4 and the inner circle radius is 2.8. Now you must show this, okay? This meaning show every value substitute. Pi you can leave like that, and I've deliberately left it there so that we don't end up writing 3.14 and the error gets compounded, the rounding off error gets compounded. But make sure you show all the substitute values. That's something that the IB requires, okay? No, don't just put it on the calculator. So now let's just switch to the calculate screen and add the calculator, and just as we entered the expression, I'm just going to enter it the same way. So I'm going to pull out the syntax for the division sign, and here I'm going to type in 72, and there you go, 360, and arrow out, give me a multiplication sign. Here's the pi key, all right? So I'm going to write pi as it was, as explained. Why? Okay, so that we are not compounding the errors of rounding off. 4 square minus 2.8 square, 2.8 square, okay, close the bracket, and when you hit enter, you get the value 5.13, and I think that should justify, right? Because if you're getting this as 5.13, since it's area, make sure you write down the units, okay? So then you can write down the justification. You can say since 5.13 meters square is clearly less than 6 meters square, Maureen has enough orange dye. I hope it's clearly visible, or in some ways visible because I'm going over that barcode. Has enough orange dye to cover the shaded region, okay? Now, I know that in your IB, you're not supposed to go over or outside of that box. Please excuse me for this time, okay? Because I'm just trying to, yeah, never mind. Excuse me is all I can say. Part B in this question, calculate the distance. Before we go to the distance, I think something else is here. We need to read that. During the game, the players start at the entrance and must travel only along the paths made in the snow. So where is this entrance? Here's the entrance. And they should only travel along the paths. So these are the paths that's made. Okay, this, if I just mark that in green, that's the game apparently. Interesting game. All right, so what are they asking? Maureen travels from the entrance along the path shown in the following diagram. Calculate the distance. Length of the arc, okay? Calculate the distance Maureen travels along this path, starting from the entrance, returning the path. That's great. So it's the length of the arc. How many arcs do we have? You've got 1 arc here, 2 arc, 3, 1, 2, 3, and then you've got radius, the outer radius, okay? So basically it's 3 times the length of the outer arc, the arc of the outer circle, and the radius, twice the radius. So I'm going to do it here on this side, okay? So do we have space under here? We don't. Did it take so much space? Wow. Students, this is something important, okay? So even though it's complete solutions, this is strange. Seriously, we don't have space, okay? If you are running out of space, make sure you write down in a separate piece of paper, or separate paper, not a piece of paper. Ask the teacher and make sure you write down continued, okay? Don't do something like this, okay? Don't do something like this. Meaning don't go outside of the block. But if you think that you're not able to, if you're not able to, you'll be unable to fit your answer here, I think it's a good idea. Just take an extra, the supplements that they provide, and make sure you write down that, continued in that paper if it's a continuation, or you can write down answered in the supplements, okay? But make sure there in that answer sheet, you write down the correct question number 1A, all those small things, okay? But important things. So B part, okay, we are talking about the length of the arc, right? So what will I write down? And always use the language given in the question, okay? So calculate the distance. So we have to write down distance, although it's a formula for the length of the arc, okay? So I'll just write down required distance. I like to use that word required, because rather than, what's the path, it's not even labeled like A, B, C, D or something like that. Required distance, because they said calculate the distance. The same thing I put here as required area. Can you see that? Required area and required distance. So the required distance is basically, as I said, it's 3 times the length of the arc. Now the formula for the length of the arc with the angle in degrees should be theta over 360 times 2 pi r. That's the length of one arc. But how many arcs do we have? We've got 3 such arcs. So this is 3 times that. Plus, we've got the radius of the circle, which is 4. So it's 2 times that radius. Okay, so 2 times 4. Again, show the substitution. Okay, so this is 3 times. I'm going to write that in a different color. 3 times 72 over 360 times 2 times pi times the radius of the outer circle. It's the radius of the outer circle because it's the length of the arc of the outer circle, right? So, and then 2 times 4, you can write it as 8 if you want to. And this expression, I'm going to edit it as it is on my calculator, right? Just as it is. So how do we write that? 3 into, and that template for the ratio of 2 numbers, 72, divided by 360. And what do we have? Times the multiplication sign, 2 times pi. Again, use the pi key. Don't use 3.14 here because you'll be compounding the error occurring from rounding off, that is, okay, 2 pi r. And close the bracket, and we can put a plus 8. And what do we have? We got 23.1. So this is 23. Let me make sure I've shifted the screen. 23.1 meters. Don't forget to mention the units also. So meters, and the earlier one was meters square. We mentioned that. All right then, how are we doing with time? Oops, I'm so sorry. We were able to solve just one question, but that was my intention anyway. I didn't want to just solve. I wanted to explain, logically, but not just solve, but also, offer tips, keeping the examination, IB examination in mind. So having said that, if you found this video useful in any way, please make sure that you like, share, and subscribe to my channel. And don't miss the next part also. We have to solve this entire paper. So when you go to my channel, if you see other videos, and if you have ideas and suggestions, questions, doubts that you want me to make a video of, let me know and I'll do it for you.